I hope you all are well. Actually, I'm not in JB now, so need to arrange few things. Anyway, so when I explained my at the beginning of the chapter, like ordinary differential equation, initial value problem, I already explained about the Euler method, right? So in short, the Euler method, we can say that the new value should be equal to the old value, and then multiplied by slope, and that's times the distance, right? So I already explained the things like how you can solve the problem using Euler method, and I also explained a little bit about the Runge-Kutta method. The Runge-Kutta method, as I said before, it will give you the precise result. Okay, that is more accurate if you compare with the Euler method, but it takes time. Okay, it takes computation time. So if you are thinking about the accuracy, so you need to go for RK method, and if you want to go for the fast result, just to have some initial guess, you can use Euler method. Okay, so but normally when we try to solve any problem, we prefer Runge-Kutta method. And in case of Runge-Kutta method, you need to know that there are different types of formation. Okay, in my last class, I said that we have actually 4 unknown, but we have 3 equations. Okay, so that's why uh, the solution is not unique. So we need to give the solution based on one assumption, right? So in this case, A1 and A2 is summation is 1. So you can consider A2 some value, and based on that, we can have the solution. So if you consider A2 is equal to half, so this is the RK method, the 2 method, okay, second order, and this one is known as the Hume's method, okay. So the formation is like this: the old value, new value will be old value plus we have this half k1 plus half k2 multiplied by h. This expression should be maybe is given to you or may not be given, because the class test I'm not sure, like because this time I will not set the question, so better you remember the things. Okay. So honestly, we actually focus on the RK2 method and RK4. RK4 is very important. I mean the fourth order expression. So honestly, the expressions are different, okay, but the way we solve is actually absolutely same like Euler method. Okay, there is no difference on that note. So you can see this is the expression. So I don't have the digital board, so I just try to use my mouse. Okay, so you can see that if you want to get the new value, the old value, this should be given to you. Of course, this is the initial value problem, so this value should be given to you. Plus, you need to know the half k1 and half k2 multiplied by h. H you also know, right? So the smaller the h you consider, the better result you will get. So the only thing that you don't know is k1 and k2. So k1 is actually f of x1, xi, yi. This is the function. That is the derivative, ordinary differential equation. That is the derivative of the function. So that will be given to you, right? So y by dx or whatever it is, the derivative, because it is ODE, ordinary differential equation. So differential equation will be provided already to you, and in that equation you just put the value of x and xi and yi, or I mean the initial values. Okay, so you will get the k1. And when you will get k2, you will use the same derivative, but instead of xi, x coordinate, you will put x coordinate plus h. This value you already know. So you have to calculate this one. So this will be your summation, that will be your x coordinate. And in case of y, you will yi, that is the value that you will get, that is given to you, plus k1, the value that you already got the k1, you need to consider this k1 multiplied by h. So honestly, if you see this xi, yi, but in this case xi plus h, yi plus k1h. If you know this coordinate and this coordinate, so just put these two values in your equation and you will get the result. Okay, I will show you some examples later on, then that will be make the things clear, more clear. So here you can see this is a midpoint method, so we consider A2 is half. So this is the solution. So we have only K2, but in order to calculate the K2, you need also K1, right? So these are some expressions. This is the Ralston method. Normally we rarely use these things in our classes. Okay, we mainly focus on RK2 and RK4 method. So there are different types of expressions. So in order to get the same thing, you need to calculate k1 and k2. Most of the time, k1 is the function, derivative function that is given, and k2 you need to calculate using some expressions. So the expressions you need to remember, or sometimes is always also given with the problem. Okay, so this one they say that you can solve this problem, that's derivative. So this is y prime or f of xy, whatever it is, but this is not a function of y. But it could be a function of y, that should be okay. But this derivative is minus 2x cubed plus 12x square minus 20x plus 8.5. So you have to find out the solution. Solution means you have to find out the value of y. Okay. Solution means you have to find out the value of y from x is equal to 0 to x is equal to 4. So you start from x is equal to 0 and you have to consider x is equal to 4. And this one actually did I explain? I think so. Okay, so we consider the step size is 0.5. Okay, so you start with 0, then 0.5, then 1, then 1.5, then 2, 2.5, 3, 3.5, 4. So you have to consider this step. You cannot jump from x is equal to 0 to x is equal to 4 by considering the step size 4 is not possible because they already mentioned this one. So you have to use the one by one step one. So we use the condition for x is equal to 0 and we will get the value at x is equal to 0.5. Then again we will use the condition for x is equal to 0.5 and then we will get the solution for x is equal to 1. So we just consider step, okay? Then we reach to the destination. And this is the initial value problem. Of course, in order to get the solution at x is equal to 0.5 based on the condition or at x is equal to 0. So the condition is given at x is equal to 0, your value is y is equal to 1. Okay. Then they said that you have to solve this one using second order RK algorithm, the Hume's method without correction factor. This one correlation iteration, so this is not that much important. Just you need to consider the Euler method, we have midpoint method, the Raster method, and we have Hume's method. Okay, so these are different version of RK method. So if they consider Hume's method, so this is your solution. In case of midpoint, this is the condition, and in case of Raster, this is the condition. But these are different form of RK method, and these all are actually second order. Okay, Runge-Kutta method of second order. The Hume's method is most popular, but Runge-Kutta method, RK2 method, we have 1, 2, and 3 different versions. Okay, so if they say that RK2, so normally we prefer to use Hume's method, but if they mention the Euler method or midpoint method or Raster method, you have to use this expression. Okay, so as you know that, so here they consider, which one they consider, maybe midpoint. So the solution, you can see this new value will be old value plus K2H, right? So this one is which solution they use. I think they use midpoint, the solution, okay? They use the midpoint method here. Okay, so you know that whether you use midpoint or anything, so you need to use K1 and K2, okay? So K1 will be, if you remember, this is just an example to make you understand. K1 is this derivative. K1 is most of the time is the derivative. So derivative is already given here. Okay, so this derivative expression is minus 2x cubed plus 12x square minus 20x plus 8.5. So your K1 will be this expression, but the value of K1 you need to consider the point, which point at the starting point. At the starting point is x is equal to 0. Your y is equal to 1. So in this case, this is actually a function of x, right? So you need to put x is equal to 0. So here you can see they put the x is equal to 0 because you need to consider the initial condition, that is the initial value. So initially you are at x is equal to 0, right? So maybe sometimes you will find that this is also a function of x and y. You can see this is x and y. This is wrote like this. So it could be like this, minus 2x cubed plus 12x square y minus 20y plus 8.5. So then you can see that the function is actually x and y. But honestly, in this case, it's only x, right? But it could be a function of x and y. So at that time, you need to put x is equal to 0, y is equal to 1. Remember, because here we don't have the y value here. So that's why we just put x is equal to 0. But it's not always like that. It could be a blended term. It could be a nonlinear term. So it could have x and y, dependent and independent variable together. So in that case, you need to put x is equal to 0 and y is equal to y. The main thing is you need to consider the initial condition, substitute that. So what is the value of k1 at your initial condition? So that is the value of this one, right? So here we don't have y, so we no need to substitute. There is no option to substitute y is equal to 1. But yes, we have x, so we put the x is equal to 0. And then value that you will get, that is the value of k1. Similarly, so when you consider k2, so if you go, which method we are using this method, right? So k2 is actually, instead of considering x, we consider x plus half h. And instead of considering y, in this case, we are considering yi plus half k1h. So what you need to do, you need to calculate these values, okay? You need to calculate this one. So xi plus half h, what does it mean? How much is this in this case? Xi is 0 plus half of h is 0.5. So half of 0.5 is 0.25, right? So in this case, when you calculate the k2, your value will get, the x value will be 0.25. And the y value, but fortunately there is no y inside the expression. But if you got y inside the expression, so that y value will be, for an example, this yi, that is the initial condition of the value, I mean this one, plus half of k1h. So for an example, if you have y inside the expression, so your y value should be, y1 is, yi is actually 1, right? So 1, right? So 1 plus then half of k1. So k1 value is 0.25. So 1 plus half 0.25 multiplied by 0.5. H is 0.5. So you can calculate how much. So 1 plus half of 0.25 multiplied by 0.5. So whatever value you will get, that will be your value of y. So what kind of expression or whatever expression you got in this coordinate, okay, just you simplify, substitute the value and get the representative x and y for that function, and then put the value there. That's very easy. So in this case, we don't have y, so even you calculate y, we know we have no option to put. So in this case, x is actually 0 plus half of h, it means 0.25. So what we do here is very simple. Instead of putting the 0, we put the 0.25. You can see the same expression, we just put 0.25 and get the value. You can see now your k1 and k2 already available. So this is very, very easy, okay? In this case, just you calculate this representative x and representative y, and then substitute this x and y in the derivative. Then you will get the k1 and k2. First you get k1, and then you need to calculate the representative x and y for k2 and substitute in the equation. And then you will get the result. The result means the k2 value. So finally, your k1 and k2 already done, right? So after that, your new value will be your old value plus k2h. So normally we use the programming, okay? So because it's time consuming. Every time you need to calculate k1 and k2, considering the initial condition and forecast the future. So this new value will be old value, that is y1 plus k2, because in this case we don't have k1 in the main expression, we are using midpoint. So k2 value you will use here multiplied by h. So that is your value, the solution. And actual true value you can get it, right? So if you just integrate it, you can get the value of y and put the value of x is equal to 0, y is equal to 1. So you will get the true solution. So you can get the error. So remember this, all the things is only for one step. Next time, so you already considered the initial condition at x is equal to 0. You forecasted the value of y at x is equal to 0.5. Okay, so x is equal to 0, your true value is 1. And then, sorry. So when you have x is equal to 0.5, you already get this value. Okay, this is true value. As I said, like you need to integrate it. You will get the actual analytical solution, and then you put the value of x is equal to 0, y is equal to 1. You will get the true value. So in this case, the error is this much. Okay, so what you will do for the next step. So now you already have 0.5. Now you need to focus one step ahead. That is the value of x at x y is equal to the value of y at x is equal to 1. Okay, so in that case, when you consider this part, you need to consider the initial condition at x is equal to 0.5. So next time, I mean, when you will do the things, I don't have the pen here to write, but just try. I'm trying to say slowly. Okay. So initially, what we have, x is equal to what we had, x is equal to 0, right, and y is equal to 1. So that is the condition that then we focus the value of y at x is equal to 1. So for the next step, your x should be 0.5 and your y should be how much? 3.10 or this 4 digit. Okay. So now you forget. Now you do the same thing for x is equal to 0.5 and y is equal to 3.1093. Okay, 9375. Okay, I don't have this space here. Should be, you need to use this one. So based on that, you forget about the x is equal to 0, y is equal to 1. Then do the same thing. It means you need to calculate the value of k1 for this condition. So you use the present condition, focus the future, and then make the future as a present, focus the next future. Okay, so you need to repeat the same thing again and again just by changing the condition. Just by changing the initial condition. It's like you are actually want to rise. I mean, you need to achieve the goal and you have some stairs. So you just use the stairs, support it and get another stair. And then use it as a support and get one step ahead. Okay, something like that. If you do so, then you will at last you will reach the destination. Okay, so in that case, the K1 should be minus 2.5 Q because at this condition, your x is 0.5. And on the other hand, K2 will be, what is the value of x in this case? So xi plus half h, it means 0.5 plus half 0.5. Okay, so it means 0.75. So then you repeat the same thing. This one is easy because you don't have the y expression inside the derivative. But you could have x and y, you could have ln, you could have logarithmic term, you could have complex equation. Okay, normally we never give this very simple thing. So these simple things are for to understand the concept. Okay, so that you can calculate. If you understand the thing, then whatever problem is given. So as I said, don't be afraid by seeing the expressions, the equations. You don't need to understand the things. You need to solve the problem. Okay, so we are not here to discuss about the physics or mathematics. We try to relate the things, how we can apply these methods to solve different types of problem. Okay, these are the examples. So we solve the problem. Okay, we are not focusing on why is like this equation or why is that. Anyway, so same thing you need to repeat, and then you will get what you will get. X is equal to 1. Y is equal to how much? Right. So same thing you will repeat. So if you get already, so that's why we use x0, x1. Okay, so this one may be x1. We use y1. So in this case, so you will get x2. Okay, and this y2 is how much? So similar way, so when you get x2 and y2 already ready, so you can say your x2 is this much, 1. So you already know y2 is how much. If you already know, next time your x3 will be how much? 1.3, sorry, 1.5, right? So then you need to calculate what is the y3. How much? So how to calculate that? Again, use x1 as the initial condition, you predict this one. So we are repeating the same thing, okay? Just understand the thing, and it's very, very simple. There is no complication. It's crystal clear, but you have to understand. And there are several types of, there are several ways, steps of calculations. So for each case, you need to calculate K1, K2, and then get the value. And after you get the value, make sure you already change the initial condition for your next calculation. Okay. So that's the point where the students make mistakes. So they're confused. Sometimes they use x2 is equal to 1, but yeah, they put the y2 as a maybe y1. So they mix up. Okay? When you calculate, we normally mix up the students. So this RK method is not the method to solve, what can I say, on the papers. Okay, we normally use the coding or we use the for loop because it takes time to calculate. But fortunately or unfortunately, you have to solve it on the paper, okay, for the class test or something like that. So you need to make sure that, but of course, we will not ask you to go to the destination. So we will calculate the time. Maybe we will consider only 3 steps or something like that, okay. So we will try to customize the problem for you. We try to find out whether you could solve the problem. If we understand that, okay, you can solve 2 steps or 3 steps, so it means you can solve thousands of steps, right? You already know the way to solve. Is there any question? Is it every step need to be? No. This one is to show the errors. Okay, so it means not necessary. We need to calculate the error for each step. Normally, we calculate the steps at the end of the result. Okay, sometimes we consider that calculate the same problem using, as I said, most of the time you will get this thing, solving using Euler method, solving using RK4 method or RK2 method, then compare the result. This would be the problem. Okay, so compare the result, you compare with the error with the Euler method. Okay, or true solution always given to you, and then say that calculate the error for Euler method, calculate the error for RK method. So you will see that in case of RK method, always the error is less than the Euler method when you use the Euler method. Okay, so not necessarily you need to calculate everything. So it depends on the question's demand, but this one it shows to you because you can see that with the increase, this error is actually increasing. After that is decreasing. Okay, and after the 4th step, when you already reach, you can see the error is 0. That is not true for Euler method. Euler method, you will see the error is getting bigger and bigger. So we balance it. Okay, when you gradually increase, you can see that. Okay, so I haven't explained the RK method, the figure. I will try to do that. So when you consider 0 to 4, okay, at the midpoint you will get maximum error, and then it will reduce. Remember, okay. So if you are considering 0 to 4, so at the 2 you will have maximum error, then it will be reduced. So we balance it. Okay, gradually increase, gradually decrease. So it's balanced. So for an example, if you want to calculate, so 0 to 10, okay, so at the 5 point you will get maximum error, and then it will gradually reduce. So that's how we formulate. Overall, when you reach the goal, the error is almost 0. Okay, because we don't have enough time, so I try to quickly go through those things. So we have the RK3 method. Okay, so it's actually same. So I just refer to you, spend some time, but I already explained the things in the video. So in case of 3 method, we have A1, K1, A2, K2, and A3, K3. So here we have K1, K2, K3. Okay, and we have all the coefficients. So no need to worry about this. We go to the main theme. Okay, so this is the main equation. So new value will be old value plus 1 over 6, K1 for K2 plus K3 multiplied by H, and K1 how we calculate, K2 how we calculate, K3 how we calculate. Remember that when we calculate the K2, we use K1 here. And when we calculate K3, we use K2 here, and K1 also here. So the K1 and K2 reflects at the y coordinate, not x coordinate, remember, okay? And when we consider xi, this is half of xi and then h. So normally when we consider the origin and the destination, we actually divide the whole region into 2 parts. That I will explain in the figure, okay, how the RK method solves the problem. This is the most important one, RK4. This one is the most classical method, okay? So classical 4th order RK method. This one is, we have K1, K2, K3, K4. This one is very important, and we normally use this method to solve our problem. In the math lab, you will see the ODE 45, okay? So ODE 45 is a function that utilize the RK4 method. So in this case, K1, K2, K3, very simple, okay? But we have the graph to make you understand how we actually manipulate the solution. So I'm not going through this K1, K2, how they calculate. I already explained the same thing. This is just expressions. So you have to remember it and calculate it. And remember that K1 will reflect in K2, K2 will reflect in K3, K3 will reflect on K4. Okay, so there are different types of method. We have this is a classical method. We have the RK I forgot the name. There is another method, RK modified RK. So there are several types of methods that minimize the error. Okay, so I try to explain this one problem. So this is RK method to solve. So same problem. Okay, we are solving the same problem, but here we are using RK4 method because this is very important. Okay, so method, midpoint method, we normally never use those things, and even for your classes, RK4 especially very important. RK4 and RK2. So normally we focus on the RK4 method. Okay, so here the same thing that I said, RK4 method, you use the initial condition x is equal to 0, y is equal to 1, but this problem is very simple because we don't have any y, and there we don't have any logarithmic term, we don't have any trigonometric term. Is very crystal clear to make you think, understand. Okay, so at x is equal to 0, y is equal to 1, right? So now you substitute the value. So k1, k2, k3, k4. K1 is the function itself, you put the value x is equal to 0, right? And then K2, if you remember K2 is what? Xi plus half h. This one, right? Xi plus half h, yi plus something. So yi we don't have. So xi plus half h means 0 plus half of 0.5. So instead of using x, we need to use this one. You can calculate this one. This 0.5 multiplied by 0.5 is 0.25. You can calculate and then substitute 0.5 here also, no problem. K3, if you want to calculate K3, the x coordinate is same, right? X2 and X3, sorry, for K2 and K3, the x coordinate is same, so we also use the same. And in case of K4, we have xi plus h, not half h. So xi plus h means 0 plus 0.5 is 0.5. So you have K1, K2, K3, K4 ready. So your future goal, the future predicted value will be old value plus half of 1 over 6 k1 plus 2 k2 plus 2 k3 plus k4 multiplied by h. So the value of y at x is equal to 0.5 will be, because the value of y at x is equal to 0 is 1, initial value is 1, plus half of this value multiplied by h, you will get this. So that is your value of y at x is equal to 0.5. So you have to repeat the thing. So it depends on how many steps or what is the destination. If it is considering x is equal to 4, what is the value of y? Then x is equal, you have to find out the value of y at x is equal to 0.5, then 1, then 1.5, then 2, then 2.5, and 3. So for each step, you have to repeat all this calculation. And just do the same thing, but change the initial condition, okay? So in this case, your x is 0. For the next step, your x will be 0.5. After that, your x will be 1, something like that, okay? And use the value of y, because here, as I said, the function doesn't contain the y, but most of the time it will contain. So in that case, you have to utilize the value of y. So don't say that I just substitute here only x. So if there is y, what I will do is not like that, okay? It could be blended terms, but for this case is like that. But if you have y, your value of y coordinate, representative y will be this way, y1 plus half h k1. Okay. So as I said, it's also saying so 0.5. They repeat the same thing, but then this you will get 0.1. Okay, so again, so that's the way it is solved. They just consider 0.1, so you have to continue like this. So I hope you understand. If there is any question, you can type or ask. Okay, even during my lecture, no problem. So there is another problem. You can see that here. X and y, yeah. So now you can see this is a function of x and y. So I request you to solve this problem using RK4 method. Please solve the problem and WhatsApp to me. I will cross check. Okay. So here the x is equal to 0. You have to consider only 0.5, only one step. Okay, just try one step. And the initial condition, this one you have to understand. This one means the value of y is 2 at x is equal to 0. It means functional value at x is equal to 0 should be 2. This is the mathematical way of representing. Okay. In this, how many iteration? It depends on the lecturer, but of course, it depends on the time also, right? Maybe 2 or 3, maybe. So as I say, the 30 minutes is actually when we consider the face-to-face class test. You have the preparation, right? So initially, maybe when you solve the one problem, you are very slow, but then you speed up. But in this case, online class test, There is no way to do that. Okay, so you can do things like you need to start writing, maybe I don't know, 5 or 10 minutes before to practice, and then make your hand faster writing, and then you can accelerate, because it takes time to accelerate, I understand. But this is the disadvantage of taking online. But there is always, we are not monitoring you, right? So I don't know what is going on behind. So that is our disadvantage, and you also have some disadvantage. So it's all actually crossed down. So how many iterations? Maybe 2 or 3. So, but we know that if the expression is very simple, you can go for 3 or 4 iterations. If the expression is like this is also very simple. But if there is some time to understand the equations, you have to derive the equations. So we allocate the time for that. So what we do, lecturer, solve the problem first. If it takes 20 minutes for us, we give you 30 minutes, 10 minutes extra for the students. Okay. But make sure like you already know how to solve. Okay? It's not like you understand the problem and there are no ways to understand it. Okay? You need to grab the things just instantly and start solving. And when you start to solve, you discover the new things and new things. Okay, so that's the way. Okay. So what are those things? So we have some MATLAB functions. So this one I already explained in my video. So you please go through those things. Okay, so I will not focus here. So as I said, this is you can see xy square plus y. This ODE 23. We have ODE 45. These are the built-in program in the MATLAB. So we can use those things to solve the problem. So this is order n, but hold on. No, where is that? It's differentiation. 1 minute, I try to find out. Linear numerical integration. Hold on, I just want to share the book. Okay, I cannot find.